Hello, I'm here to talk a little bit about window.ipfs, how it's implemented, why it's implemented the way it is, and just basically a little bit about how it works. So the idea is, so we've got this issue here where we're trying to expose our IPFS instance that's running in the extension on the window object of every web page that you visit. The thing about that is that it's not just as simple as put it on the window object. Web extensions, they run in isolated environments. They are their own process. So we can't really share instances between web pages and the browser extension. Now, web extensions have the concept of content scripts, which are scripts that you can run on every page. And content scripts also have an isolated environment, but they share the DOM with the web page that they're running on. So they can make changes to DOM elements, but they can't, for instance, add an object to window, because if they do add it in their environment, then the web page doesn't see that change. It's not the same window object, basically. So they can't do that, but what they can do, because they have access to the same DOM, is that they can add a DOM element, which is a script, and the script can then add things to the window. So that's exactly what the kind of proposal is. But then there's the problem of actually communicating between a web page and the web extension, and because they're kind of isolated processes, they don't share memory, and there's no way of kind of doing that aside from using Postmessage APIs, so window.postmessage. In web extensions, you can set up the idea of a port between like a content script and the background process for your web extension, and that has a similar kind of postmessage kind of communication channel. And what Postmessage does was essentially makes a copy of any data that you want to send across, so nothing is ever shared. So that's how that works, and that's how window.postmessage works. So how is that relevant to window.ipfs? Well, when we want to put something on our window.ipfs, we can't use the object that is the instance of IPFS that's running in our web extension, but we can create some sort of object that will look like an IPFS and use this post-message communication channel to call functions on a remote IPFS instance which is running in the web extension. So Q this Postmessage Proxy. This is essentially what I've just described. It's a IPFS, a window.ipfs thing that looks like an IPFS with lots of call stubs on it. That when you call those call stubs, what they do is they take their arguments and they pass them over window.postmessage to the browser extension, and the browser extension has exposed methods on the JS IPFS instance to be called via this Postmessage messaging. And then so at a lower level, what IPFS Postmessage Proxy is using is this module called Postmessage RPC, which allows us to create these call stubs and expose these functions on our IPFS instance, and basically smooth over the fact that we need to use Postmessage and attach listeners and unpack the message and things like that. So Postmessage RPC is just a simple, small library to give us kind of remote procedure call over Postmessage. So let's just take a quick look at how that's used. Postmessage RPC, npm install it, and then we can import a function called expose. So this is kind of the server side, the side on which you've got something that you want to expose to your other window, basically. And so in this example, we've got a fruit service which provides fruits, and this fruit service has a getFruits method, and it takes a bunch of arguments and returns a promise. So Postmessage RPC assumes we're working with promises, promise-based APIs, because then we can use await and fun things like that. So what we're saying here is we've got our existing fruit service. What we're doing is we're exposing a function called getFruits. So this is the name of the function that the other side will call, and that maps to this function on the fruit service called getFruits. So when the client side calls a function called getFruits, what will actually get called is this getFruits function on the fruit service. And then we don't have to think about window.postmessage or attaching event listeners or removing them or any of that stuff. It just works. And then on the client side, the thing that's wanting to use the fruit service, so in our case this will be like the window.ipfs, we can import a function called call from Postmessage RPC, and it allows us to call our getFruits function in the other window. So the idea is kind of you can use this as we are with web extensions, but you could also have a window with an iframe in it with something in the iframe that has exposed a bunch of functions, and in the window that is containing the iframe, you can call functions on that other window. So that's kind of fun. So what we actually do in most instances is we use caller from Postmessage RPC in Postmessage Proxy because it allows us to create a function that we can call over and over again, and also pass some options to Postmessage RPC to configure other basic things that we need from post messaging. So in this instance, what we do is, this is equivalent to this down here, but what we're doing is we're creating a function using caller which will call getFruits, and then what we want to do is get the fruits again, and instead of calling call with an argument of getFruits, we've got a function that we can just call with the argument. So that's kind of fun. And that's exactly what we're doing with IPFS, window.ipfs. It's just got it's an object with a bunch of functions attached to it, which are caller functions for like window.files.add, window.block.new, ipfs.block.new, all of that. So that's it at its base level. Now, with copying function arguments across Postmessage, this is fine as long as all of your data is JSON stringifiable. What actually happens is in the browser is if you're using Postmessage, it uses something called the structured clone algorithm, which allows you to pass a few more data types than JSON supports. But it does, even then, there is some data types like your own data types, your own classes, and other things that you can't just pass to structured clone algorithm and get exactly the same thing back on the other side. So there does need to be some serialization of some of the arguments that we pass to our IPFS functions, because sometimes they expect things like CID objects or DAG node objects, and before they can go over Postmessage, be copied, they need to be kind of serialized into a format that is just numbers and strings and arrays and stuff like that, and then deserialized on the other side back into a DAG node or back into a CID. So to do that, what we do is we use what IPFS Postmessage Proxy uses is a module called prepost, and this is just a way of altering arguments before a function is called and altering return values after a function is called. So this is kind of a little bit like middleware for functions, but let's just have a look at the example here. So we're importing pre, and we've got our function here, which is add two numbers together. That's great. And what we do is we create another function, which is double add. We call pre, and we give it we can call pre with as many pre functions as we want. So this could be like a second one, a third one, and then eventually at the end is the function we actually want to be called. And pre returns a new function, which when it's called, it will call the pre functions, and eventually call the function that we want to call. And what the pre-functions do is they take the arguments as they would be taken to a call to add, and what you're expected to do is return an array of new arguments. So they could be exactly the same, they could be doubled as they are here, or you could have more or less arguments, and that is passed on to the next pre-function, the next one, but eventually it's passed on to the add function. So I said this can return an array, but it can also return a promise, so you can do some async stuff in there. But if you return a promise, it has to resolve to an array of arguments to pass on to add. So that's that. So what this specific example is doing is it's got a pre-function which takes 2 arguments, and what it does is it returns new arguments that are doubled, and then it calls add. And so that's pre. And what that allows us to do in the scope of IPFS Postmessage Proxy is it allows us to take arguments to a function like CIDs or DAG nodes and serialize them before they are passed to our caller stubs. And then when they're passed to our caller stubs, when they go over Postmessage, they can be cloned or copied or whatever happens to them without losing any information. So that's how we do that. And on the other side, on the server side, we use post, and post does something similar, except you give it the function that you want to be called, and you give it a bunch of post functions to call after the result for the function you want to call has been calculated. And you can have as many of these as you want. In this case, we've just got 1. And what we're doing here is we're timesing the result, the return value, by 2. So we can just return a regular object or whatever from JavaScript, but we can also return a promise for async stuff. So you can also do async on the post side as well. So this is doing exactly the same thing as the example above, as in it's creating a function that will double the result, and we get the same output value, but actually internally the way it's going about it is slightly different. And so then on the client side, where we have our stubs, we use post to deserialize, or so on the server side we use post to deserialize arguments that have been serialized using pre, and also for return values we do exactly the same on the client side. So we use pre and post quite a lot to just deserialize and serialize the arguments and return values from our IPFS, which is kind of rad. So let's maybe take a look at some code, because I've talked a lot and this may have just gone straight over your head. So what we're looking at here is we are in the server side. So this is the side that's running, for us, we'll be running in our web extension. And we are looking at block, and I'm going to just talk you through block.stat. So what you can see here, what we're doing was we're exposing a function, and we're going to call that function ipfs.block.stat. Makes sense. And then what we're doing is we are using our pre here, but actually what our main call function is this function here. And what this does is it takes some arguments and it calls our getIPFS function, which gives us back our instance, and then we call block.stat with those arguments. And then we've wrapped that in a pre, and what that pre does is it's got a pre function here, which takes some arguments. So these are the arguments that have been passed to this function after they've been serialized and passed over Postmessage. And what we're doing is we're deserializing at this stage, because we are taking our buffer, because we can pass as the first argument to block.stat a buffer, which is it's a CID as a buffer, or a multi-hash, whatever, or if it's a CID, serialized CID, then it creates a new CID instance from this JSON. and then we return arguments. And then, so the second pre-function, this can be null, but basically in IPFS Postmessage Proxy, this allows us to add some extra processing to the consumer of this module, which is going to be IPFS Companion. And in this instance, this will, for IPFS Companion, we're going to add a pre-function which will ask the user if it's okay that the caller calls this function. If it's and we can, because pre-functions can return promises, that can take as long as we like, but it can also throw and deny access. So that's kind of cool. So anyway, after these pre-functions have run, we should have a bunch of arguments that have been inflated from our serialized values back to buffers or CIDs, depending on what you passed. And then IPFS block.stat is called, and the value is returned to the caller. And so on the client side, what happens is we use caller to create a function that can be called, and then we wrap that in a pre, and that pre is going to take the arguments that we were given, and if it's a buffer, then we will serialize it to JSON. If it's a CID, we'll serialize it to JSON, and then we return the arguments. And then that is wrapped in this. This is a module which will take a function that is promise-based and turn it into a callback if you pass a callback. So that's just plumbing fun. And that's about all I wanted to say. Have you got any questions? If so, put them on the comments, and it was nice to talk to you. Bye.